Alright, first flight. Let's power this up. Okay, let's try arming.
Motors on. Stabilize flight mode.
Rolling left and right, and forward and back, and pitch is reverse, which is quite common on Cirrus F. And if I just
Landing complete. Landing complete.
and you can also hear that little zzz oscillation on the copter, which means probably the PIDs are overtuned, but also
Motors descend.
no harmonic notch setup. So next thing to do is set up the harmonic notch, filters and reverse pitch and see what it looks like. Alright, so let's reverse the pitch, which is RC2, reversed, go, and then the harmonic notch, so we're going to enable harmonic notch. That should give us a few more parameters. We've got those there. So now mode is going to be 3 for ESC. Ref is going to be 1 for ESC. And then ops. Usually with ops, definitely want multi-source. Definitely want loop rate. Probably want triple notch. Okay, so we can do that. And then bandwidth. Okay, so because it's ESC telemetry, we really want the bandwidth to be a quarter. So the Q factor of 4, quarter of the frequency. Let's set this to 20. 80 is probably low enough. This is a little copter with very high RPM motors, so 80 is probably easily low enough. So I think that should be good. And then we'll have a quick look at the PIDs. So this is default PIDs at the moment. Default PIDs, almost certainly overtuned here, but only a 3S battery, so it's not super powered like some of my 6S copters. So, I mean, interestingly, it didn't go to the moon. So it'd be interesting to see what these PIDs look like. I'll try these on default PIDs again, flying with the harmonic notch configured. Let's just see what the gyro. It's a gyro filter 134. That's quite high, but that's okay. Filter D. So somehow the little wizard has calculated probably reasonable values for these. So we'll have a look. And then the other thing I wanted to just do is flight modes. So I've only got stabilized here, so I think quite like this one to be alt hold. This one stabilize, this one acro. That's what I usually like. Not much point in having anything else because there's no GPS at the moment. And then the other one is, let's see, radio calibration. So this one, radio 9. So I'm going to make that E stop here. So somewhere here. Motor emergency stop. There we go. So that just allows me to cut the power to the motors easily. Alright, so give that another go.
Telemetry lost. Telemetry recovered.
Alright,
Motors armed.
just check E-stop. That works.
Motors disarmed.
Okay,
Motors armed.
let's try a bit more of a hover.
Motors disarmed.
And you can see that the although the noise is killed with the harmonic notch, it's still quite a lot of oscillation that basically means the PIDs are too high, so I'm going to soften those quite considerably. Alright, so back to the PIDs. So I'm probably going to try halving all of these, so see what that looks like. So get out my trusty calculator. 0.135, so 0.0675. And then D, .0018. And then yaw I'll just leave alone for now, I think. I will change the filtering on yaw. So yaw filtering usually is best at quarter of the gyro rate. So that makes it 34 Hertz. See? Alright. So we'll have another little test flight.
Telemetry recovered.
Right, arming.
Motors armed.
So you can see that the oscillation is gone there. It's quite soft, the control is quite soft, so clearly the PIDs are now too low, but they're not too bad, and it's probably enough for getting into alt hold and running auto tune, which I think I should try next. I mean, I suppose probably the thing to do is quickly do a log just to check the noise, so I will just do that.